Right, in our previous video, we looked at the idea of different types of very simple types of algorithms in terms of encryption and decryption. We said one where we could shift all the letters up, and the other sometimes known as shift algorithms, famously used by Julius Caesar and during the war as well. And then the other one we did was simple substitution ones, where each letter, instead of using a particular letter, we used an alternative letter. Essentially a corresponding one. So if we had 13 letters of the alphabet, random letters of the alphabet, and we wrote down the other 13 letters of the alphabet, we would just swap them depending on their position. So if there was an A or whatever it would swap with the corresponding one. So essentially what we need to do is come up with two lists or sets of letters, and we're going to call them S-master 1 and S-master 2. And we touched on the fact that we can take note of uppercase and lowercase, but why not just build it into our encryption keys, and then we don't have to worry about that. So the only thing we have to worry about, if we want to, is punctuation marks, like question marks. But for the meantime, we'll just concern ourselves with the different letters of the alphabet, uppercase and lowercase. So I've created a constant string here at the top called S-master. Okay, so sort of loose Delphi that I'm using here, and I've written down all the letters of the alphabet. I'd make sure that you get them all the capital ones followed by all the little ones. And we always say, if you can't solve the problem in real life, forget about trying to write a code for it. Okay, so we need to solve it in real life and say, how did we go about it? What was the algorithm we actually used? Because sometimes we don't even actually realize it because our minds are so smart and so quick. We're going to do it. So essentially what we do is, let's just think about these steps, keep them in the back of the mind as we go along. So essentially my immediate problem is I've got 52 characters, the 26 uppercase and the 26 lowercase, and I said we're excluding punctuation. At this stage we could include that later. It wouldn't significantly change our algorithm. So essentially the approach I'm going to do is I'm going to say, right, imagine this is all on a piece of paper and you've got a pen, and you're just randomly going to point your pen at a letter in the alphabet and say, right, I'm going to click on there. Okay, I've got the Q. Okay, I'm going to take this Q and I'm going to put it into there. Okay, and I'm obviously going to delete that position there. I could leave it and check if it was blank. Okay, but I'm going to delete that from there. And so instead of having 52 characters now, I've got 51 characters left there. Okay, I'm just going to make it a bit wider so we can see there. So I've got 51 characters there. Okay, so essentially what I'm going to do is I'm going to keep on taking characters out of that master one, and I'm going to populate these two ones over here. Now, two ways we could go about it. We could fill up the master one first, or we could fill them up one. You know, like you pick teams when you've got a whole lot of people. You say, right, you're my team, you're on that team, you're on that team, you're on this team. Okay, let's use that approach. Not sure if it's statistically any stronger, but let's use that approach. Okay, so I just randomly chose that one. Okay. So that's that, and I would then, and you can see there's sort of a pattern forming here. Okay, so now I would be down to 50. Okay, so every time I choose two of them, and I put the one in the first list, and I put the other one in the second list. Okay, I made this equal to a blank string to start off with. Okay, so technically those positions don't exist to start off with. I'm just put it there to illustrate how the strings are going to grow. Okay, so the computer's going to do this for us. Okay, it's going to generate this random thing for us instead of us having to play this random role like we're doing now. Okay, so that's once, and that seems to be the basic pattern, is that I just need to repeat that pattern a few times. And if we think about it, if there were 52 characters in total, and every time I get rid of two, or not get rid of, but place them in the two separate master codes, I need to do this 26 times. So already, okay, in other words, half the number of characters in the string. Okay, but let's not get too fussed about it, but those are some things that are at the back of my mind at this stage. But let's carry on with this process. Okay, so take another random one. I don't know. Let's stop here. Random. Okay, my random choice there was another Q. Okay, and I would delete that. Okay, so now I'm reducing that one there as well. And I would delete that one, and now I would have 49 characters left. in that thing. Okay, or I could repeat this process until there are no more characters left. Because that's essentially what I'm going to do. We're a long way off from that, but okay, let's choose another one. I'm trying to be random here. Okay, C. Okay, should I take the C? Yeah, let's take the C. I want to go to the C. Oops, a daisy. Okay, I want to take the C out of there, and I'm going to paste it there. Okay. That's a C. And then I would go down to, I've got 48 characters left in that string. And this process is going to go on and on and on until I've distributed all of those characters between the two strings. Okay, so I'm going to pause the video, quickly distribute them randomly between them, and then we'll talk about what we've got afterwards. Okay. Right. So when I come back, we're going to just do this leap forward in time, like Marty McFly, and let's see what happens. Right, I've jumped into the future. I've only got 10 more characters left to allocate. As you can see, I've got 21 in each of them so far, because I've been allocating them 1, 1, 1, 1, 1, 1. Okay, like much as I say, like you would choose a team there. Okay, and just remember that when I take it from here, I delete. Okay, so you might say, well, okay, and then I'm down to 9 characters. So how would I choose a random one? Okay, well, if I know how many characters there are 9 characters left there, then if I choose a random number between 1 and 9, so I could say, give me a random number between 1 and 9, and you'll say, okay, well, 8. Okay, then I would take that one out, and I would fill the bottom one, and then we would be down. Okay, that would then be deleted from the string. Okay, so I'm just trying to simulate that here, not that successfully, but you get the idea. Now I'm down to 8, and I'd say, right, well, let's repeat that process again. Give me a random number between 1 and 8, and you say 2. Okay, so I'll put the 2 there. Okay, so that we know there are some random number functions in Delphi, but again, we're jumping way ahead of ourselves, because we're not talking Delphi now, we're talking about algorithms, and we're talking about the solution. What I want to do here, I want to delete that column, and I'm down to, okay, so I keep on going, I keep on introducing 1, 2, 3, 4, 5, 6, 7, 8, whatever it is, and I'm going to continue this process. Okay, I'm not going to update every time, I'm just going to be a bit lazy, but you know what I would be doing, I would then be putting 1 there, I would be deleting each time, until, right, I've just jumped ahead in my space machine well, and I'm down to the last 2 because I've been allocating them 1 by 1 to here, and I'm left with this one here. I will then allocate that one to that top string over there. Then we just cut it and paste it. Okay, so there are now 26 characters in there, which is what I'd expect. And okay. No, shame. This is the person that gets picked last, unfortunately, like in some of the sports picks that we have. Okay, in the playground, delete the entire column. Okay, I'm only left with 1 now, and obviously that last one then has to be assigned over here. And I would delete that, and I would end up with what we call the empty string. In other words, I would be gradually taking those characters out, so until that string ended up being the blank string. Okay, so in other words, with 0 characters in it. Now the point is that now I've got 2 strings generated automatically. The first one here, so if I wanted to write the word code now, I would look for the word C somewhere. Okay, and it also takes place of uppercase, lowercase. So if I wanted to write code now, I would look for the uppercase C, and okay, that's in the 4th position. So the equivalent of that is in the other position. It's an H. There's the O, but I don't want the capital O, I want the small o, which is over here in the 12th position, and the corresponding one there is a G. Okay, so you can see it's actually mixing up the case sensitivity as well, okay, which probably makes it a little bit more complex to decode for somebody trying to hack it. The D becomes the capital X. Okay, and the E becomes, we just got to find the E, and what do we want? A small e, huh? Okay, you're probably saying, you're probably all shouting at me, there it is, you fool, can't you see it? There we go, and it's an M. Okay, and the important thing is the same process would be used to do that. Okay, let's see if we can try and put that into some form of algorithm quickly. Okay, this process of starting with that and ending up with those 2. Because we can do it manually. We can do it manually with a piece of paper, and and in Word like I did it here, then I can certainly write down the steps that I followed, and when I've got the steps that I followed, I can then translate that into code. Okay, we don't jump to the code. Okay, it's like translating between Greek and Spanish. Okay, you first have to, okay, it's like going from English to Greek to Spanish. You don't jump from English to Spanish, you go from English to Greek first, and then from Greek to Spanish. That's a really bad example, but hopefully it serves as a little bit of a model. Right, now that we've worked that example manually of taking this master alphabet of uppercase and lowercase, and we can add punctuation marks, and we'll do that a bit later maybe, but we had so 26 uppercase, 26 lowercase, and essentially what we did was we randomly chose something from that master, and we moved it in one by one, first one to the randomly chosen to the S master, and the second one to S master 2, and then S master 1, and we repeated that process until there weren't any more characters left. In other words, if we chose the first one, which was a Q, we chose the Q, and then we deleted it from there. So now there would be 51 characters left for the first one, and then we chose the random N. Okay, and say the computer would go and choose the random N, so you get the picture that we're following. So that string would get smaller and smaller as we took people out. So it's like choosing a team on a field. You have everybody together, and then you split them up one by one to the various to the two teams that you want the people on. Same thing with the characters. So my basic algorithm says repeat until there are no more characters left. Okay, and what did we do? Okay, the first thing we did was we chose a random position in the in a random position. How? Well, it depended on how many characters there were. So if there were 26 characters, I chose a random number between 1 and 26. Okay, so that's the first time I would have come around. And I would have said, right, choose a random from 1 to its random position in there from 1. And so let's just say, okay, give me a number between 1 and 26. So you say 14. Okay, and you would have gone to 14, and you would have taken the N out, that character, and you would have taken it from and added it and deleted it from the original master. So if you'd taken the N out, okay, we're just doing it for the first two. Okay, that would have gone down, and then that would have been, my numbering's a little bit out there, but that would have ended up with 25 characters. Okay, so that would have gone 13, 14, 15, 16, 17, 18, etc., etc., etc. Okay, I'm not going to renumber there, but now we would ultimately ended up with not 26 characters, but 25 characters, because obviously every time you take one out, there's one less to choose from. Okay, we'll go back to our sporting example again. And then I chose one for the other team, S master 2, if I could put it that way, or the other code, and choose a random position in the master alphabet, the exact same thing. So I said, okay, choose another one. I say, okay, from 1 to 26, no, from 1 to 25, I need 25 choices left. Okay, I'm going to choose the Q, capital Q or small q, capital Q. So you would take that one out, and you'd be left with 24 characters for the next one. Okay, and you would choose it, and random one, and that's essentially what we did. We chose a random position in the master alphabet from 1 to its current length, realizing that that's getting smaller each time. Take the character in that position and add it first of all to the S, to the first master key, and delete it. And then we repeat the process, but just for not the S master 1 key, but for the S master 2 key. So we go 1, 1, 1, 1, 1, 1, 1, 1, 1, until there are no more characters left. There'll always be an even number of characters here, otherwise it wouldn't make sense. We said earlier you could have extended this and added punctuation marks. So if you wanted to add the comma and a semicolon and a quotation mark, you could have, as long as you had an even number of them. Okay, you can't have, okay, to split two teams evenly, you must have an even number to start off with of possible characters or players in our example. And that's essentially our algorithm that we've got simply to set up the two master keys. Okay, so we would start with that as a constant at the top there. Is the master alphabet, and we'd assign it to, and then we would gradually reduce the characters in by randomly picking one and adding it on in one by one consecutively to first of all S master 1 and then S master 2. Okay, and if we think ahead of Delphi, if we want to, there's a way to choose a random. Now we'll look at that, where there are some random functions, and we know the length of a string we can determine as well. We can add on to strings, we know that, and then that's just a repetition, and it's just a simple checking the length of the string. So now we've got an algorithm. This is simply for just setting up the two master keys. Okay, it's not to do with encoding or decoding at this stage. It's just that we've got two different master keys at this stage. Right here.